In industrial situations, though, water hammer is more than just a noisy annoyance. Water hammer that results from localized abrupt pressure drops may never be heard, yet water hammer can acquire great force, damaging equipment, ruining product, and potentially putting personnel at risk. Water hammer begins when some force accelerates a column of water along an enclosed path. The incompressible nature of water gives it the power of a steel sledge as it slams into elbows, T's, and valves. The resulting vibrations are transmitted along the water column and piping, damaging fittings and equipment far removed from the problem source. Water hammer can occur in any water supply line, hot or cold, and its effects can be even more pronounced in biphase systems. Biphase systems contain both condensate and live or flash steam in the same space. Heat exchangers, tracer lines, steam mains, condensate return lines, and in some cases pump discharge lines may contain a biphase mix. 3 distinct conditions have been identified which provide the force that initiates water hammer. These conditions, hydraulic shock, thermal shock, and differential shock, are common to many industrial fluid applications. However, following a few simple guidelines will help you minimize the occurrence of these shocks and diminish the chance of damaging water hammer. Hydraulic shock occurs when a valve is closed too abruptly. When a water valve is open, a solid column of water moves from its source at the main to the valve outlet. This could be 100 pounds of water flowing at 10 feet per second, or about 7 miles per hour. Closing the valve suddenly is like trying to instantly stop a 100-pound hammer. A shock wave of about 600 psi slams into the valve and rebounds in all directions, expanding the piping and reflecting back and forth along the length of the system until its momentum is dissipated. By closing the valve slowly, the velocity of the water is reduced before the column is stopped. Since the momentum of the water is decreased gradually, damaging water hammer will not be produced. Sometimes check valves can produce hydraulic shock. Swing check valves are often used to prevent liquid being drawn into spaces that are subject to intermittent vacuums. They are also applied to prevent backflow from elevated systems when adequate pressure to raise the liquid cannot be guaranteed. In either case, the acceleration of the reversing column of liquid may be quite high. If the swing length of the check valve is sufficient, the column will build enough inertia to cause hydraulic shock in the time it takes the valve to slam shut. Substitute silent or non-slam check valves for swing checks to prevent water hammer in these situations. Silent check valves are center-guided to provide a much shorter stroke than swing checks. These valves also use a spring to help in closing. The result is that silent check valves are closed by the loss of upstream pressure rather than the reversal of flow, preventing hydraulic shock. Water hammer arresters, if correctly sized, placed, and maintained, will reduce water hammer. When the forward motion of the water column is stopped by the valve, part of the reversing column is forced into the water hammer arrestor. The water chamber of the arrestor expands at a rate controlled by the pressure chamber, gradually slowing the column and preventing hydraulic shock. To prevent water hammer due to hydraulic shock, avoid suddenly stopping water columns. Ensure slow closure of valves and install spring-loaded, center-guided, non-slam, or silent check valves that close before flow reversal when appropriate. Use water hammer arresters if necessary, but be sure they are sized and placed correctly and are well maintained.